Hi everybody! I figured out how you can see me and the work at the same time, so hopefully this feels a little more personal. So in a previous lesson, I went over how to randomly generate an equation in slope-intercept form, but there were some notation issues, and the fractions with the slope, so I've totally cleaned that up. Thanks to an email I received from Ruben Garcia. So he emailed me and he's like, hey, do this. So let me walk you through what he showed me and suggested. And now we will have something that, although the other one worked, and again, I really feel like you don't have to have it perfect before you can use it. But then we tweak as we go. So this is me tweaking. Okay, so I have a feeling this video is going to be a little lengthy, so, eat it in small bites. First thing I'm going to do is get all my components out. So I need a graph component, because what I want the students to do is click and drag to make the line that was randomly generated. Well, the equation that was randomly generated. So I'll need that. Somehow I got two. I only want one. I want a note component that tells them the equation. And then I also want a note component that lets them know if they're correct or not. So I'm going to have these three components out. And I'm going to label all three of them. I'm going to call this one graph 1. This will be note 1. And this will be note 1b. All right. Now, I don't know that I'll need all those labels, but there they are. And I usually name them, if you've been watching my videos, what the component is and then what the screen number is. Okay, let's start with the graph component. I'm going to edit the graph. So I'm not going into computation layer, into the edit part. And I'm going to start with the 2 points that they're going to drag around. So I'm going to call the first point AB. And the second one, CD. I don't know if it's like, did I press it? Okay. I want these to go by a step of 1. If I don't do that, then, the students aren't quite sure if they have it on the point or not. This will like jump as they go along here. This is also nice with the video because I talk with my hands a lot. That's good. So now I want the slope. And of course, this is y2 minus y1 over x2 minus x1, but I didn't label them that way. It would be d minus b over c minus a. Now the y-intercept is a little trickier. That one I solved on paper weeks ago, wrote down the formula, and now I never have to think about that again. So bc minus ad over c minus a. All right. So that would be the y-intercept of wherever they put those 2 points. And then I actually want a line going through those 2 points. So y equals mx plus z. Okay, so that's what I'm going to do in the edit graph part there of the graph component. So right here. Right there. Okay. You know what? This will make more sense after we do some other stuff. We'll come back to that later. So I'm going to set that paper aside. I am still a person who loves to write things down. All right. Now I'm going to go into this note component. I like to use this one for the feedback and then the one below it that actually gives the problem. So this is where like the bulk of the coding is going to be. So first thing I need to do is, get the random generator. So R equals random generator. We're going to leave those blank for now. Okay, now if you use, I think one will do it, but I don't know why I like 2 pound symbols. You can just make notes to yourself here. This has nothing to do with the coding. So in this part, I'm going to find the term of the equation that includes the slope. I'm just going to put, that's notes to myself. I know this is about the slope term. Now, there's a few things going on. I do want the fraction. So I need a random number for the numerator. I need a random number for the generator. Let's just, a random number for the denominator. Another problem with this is my face does not hide a thing. See, I just rolled my eyes, didn't I? Numerator will be equal to a random integer. I want it personally to be between 1 and 5. We'll work on negatives in a bit. Denominator, same thing. I think for my Algebra 1 students, having, the slope that could be like 2 over 5 or 4 over 3 is cool. I don't need to get bigger numbers to know if they know what they're doing. The smaller numbers work just fine. Now, I will want the actual slope that doesn't include the x. So I'm going to have like two slopes going on here. The slope term and the slope. I hope that makes sense. M equals the numeric value of the numerator divided by the denominator. So, quotes, then do this weird notation, numerator divided by weird notation, oops, denominator. Finish your quotes and parentheses around all of that. Why? Because computation layers said so. All right, that's my actual slope. I'm going to use this variable called slope to be the slope term. Now, there's a few things going on here. I'm going to have two when statements and an otherwise statement. So what's happening is when the numerator and denominator are equal to each other, I just want x to show up. I don't want 1x to show up, just x. When the denominator is 1, I don't want it to show like 3 over 1x. I just want it to say 3x. And then my third option will be, well, if they're different numbers and the denominator isn't 1, then just give them the fraction. It's possible that it's not completely reduced, and I'll live with that. All right, so my first option is when the numerator and denominator are equal. Okay, then what I want to happen is I only want x to appear. Now, if you leave it like this, it's going to be the regular font X. I want it in that math font. So you use that funky little, I'm coming up with my own sign language here. It's the button that's next to 1. Okay, that's how you get that. That will appear with the math X, if that makes sense. All right, my next situation is when the denominator is equal to 1. Then in that case, what I want to show up, so I'm going to put these in quotation marks, I want it to just be the numerator and then x. So again, these things. And inside there, I want the numerator, so weird notation, x. Right? Just double checking my notes. Yes. Because again, I'm still learning. All right, otherwise, I want the fraction of the numerator over denominator. So my last video was on notation, so we're going to be using some of that. So again, I want it in quotation marks. Again, I want it in math type, so I want a fraction. So for a fraction, it's / frac. And then it will be, the curly brackets will contain the numerator, then the next set of curly brackets will contain what you want in the denominator of your fraction. So in the numerator, I want the numerator. So weird notation, numerator. In this set of brackets, the weird notation of the denominator. Okay. So that takes care of my slope term. Everyone will live. Let's move on to the y-intercept. Again, that's a note to myself. For the y-intercept, I'm going to use y_int as my variable, and that's going to be a random integer. So r.int parentheses from 1 to 9. Again, we'll take care of negatives in a bit. Again, thanks to Ruben Garcia for this great idea. Okay. Switching pages now. Now the equation. For the equation, there's 4 situations we would have with the signs. One would be where the slope and the y-intercept are positive. One where they're both negative. One where the slope's positive, the y-intercept is negative, and then the 4th option is the opposite. So I want it to randomly do that. So I'm going to call this variable signs. And it's going to be a random integer from 1 to 4. Okay, now we could make notes here on, 1 represents when they're both positive, 2 represents when the slope is positive and the y-intercept is negative, but I'll figure that out, right? I don't really need to make separate notes for that. All right, now my equation that I want displayed. I'm going to have to move my face, aren't I? Here, I think this is safe for me to be there. My equation will be equal to when signs equals 1, I'm going to put all this in. When signs equals 2, when signs equals 3, and otherwise. All right, now let's go back and fill out what happens when signs is this, that, and the other thing. All right, when signs equals 1, I want positive slope, positive y-intercept. So, quotation marks. I think it's easiest to start and finish them right away and then type in the middle what you want. Yes, I am praying. All right, what I want here is I want it to say y equals, and then I want my slope term, so weird notation, slope, and that will include the x, right? Because up here I did that. So whatever slope is, it will either be like x or just the numerator in x. Ooh, I forgot it here. Do you see that? X. That was close. We got to put that in. Anyway, x is already there. I don't need to put it in. Then it will be plus the y-intercept. So weird notation, y-intercept. All right. 2 is very similar, except now equals weird notation slope minus weird notation y-intercept. Okay. Option 3 is where the slope is negative and the y-intercept is positive. So y equals negative weird notation slope plus weird notation y-intercept. And then my last option would be where they're both negative. So y equals negative slope minus y-intercept. Okay, now this is all good and fine. My problem now is some of it is in math font and some of it is not. So I'm going to go back through and surround the parts that are purple with these things. I apologize for my informal ways here. So start, finish. The plus sign needs it too. Start, finish. I bet there's a better way. And then the minus sign needs it. Okay, down here. Start, finish. Start, finish. And then my last one. gosh, this is fun. I love this. All right, so now I have my equation. Now I actually want it to show up in the note. So the content, so I want the directions and everything all wrapped up here. So I'm going to tell the students to click and drag the points to create the line and then weird notation equation. Let's view it. I want to make sure that all that math font showed up correctly. I might have to move myself again. There it is. Equation. That looks beautiful. Click and drag the points to create. Have that thought, like I just don't know what to do with myself. I literally do not know where to put myself. Let's spell create correctly. So we'll just put that E in there. Okay. Looks good. Now, I need to start doing something to make sure it's correct. Now, this numeric value of slope is positive only. So it didn't take into account like all the sign stuff. So I need that to happen. So I'm going to put here sign and value of the slope. So the real slope, I'm going to call it RM for real slope, equals, now we're going to have some if-then statements. Well, when otherwise. So when signs equals 1 or signs equals 2. So remember with our slope, it was positive when this was 1 or 2. It was negative under options 3 and 4. Okay? So when signs is 1 or 2, then the slope is what it says it is. We don't have to change the sign. So this will be the numeric value of, I'm forgetting my notation here, quotation marks, and then that weird notation for M. Okay. Otherwise signs, you know, this random number 1 to 4 would either be 3 or 4, meaning the slope is negative. So it would be the numeric value if I take -1 times M. And then remember to close your quotation marks. Okay, so now I have the real slope. It includes the numeric value of the slope and it includes the sign now. So that's great. Okay. Now same thing with the y-intercept. I should put this here. And y-intercept. My N button on my keyboard sticks. And I like to type fast. Makes me feel like a fast typer. And then the N's get in my way and force me to slow down. All right, same thing with the y-intercept. However, this time they weren't positive with 1 and 2. The y-intercepts were positive with 1 and 3. So when signs equals 1 or when signs equals 3, the numeric value is y-intercept. Okay. Otherwise, we would have to multiply it by -1. Otherwise, numeric value, quotation marks, -1 times our y-intercept. Guys, I'm telling you, I feel like $1,000,000 learning this coding. I feel like I'm in some kind of like secret society. Like only a few people know this. It's more than a few people. But it's you and me now too. That's welcome. All right, I have an error message. What don't you like here? I just said I feel like $1 million. I feel like $500,000 right now. All right, it's not like in this equal sign. Oh, so I'm going to call it ry. So the real slope is rm and the real y-intercept is ry. Okay, $1 million again. Let's give it a chance to check for the correct answer. So checking for the correct answer. I'm going to call that check. Check equals. Oh, hold on. Before we can do that, let's we got to pull in those numbers from the graph. Pull in the slope and y-intercept values from the graph. So as the students are moving the points around, you know, the slope and the y-intercept keeps changing. I want that to pull into this component. So to do that, I'm going to call it the graph slope. So we have the real slope and we have the graph slope. So I want the graph slope coming in. So where's it coming from? Well, we called that graph 1. And I want the number in that graph called m. Remember we did all that work before? What don't you like there? Now I want the y-intercept z. What am I doing? I feel like holy smokes, guys, I never finished this. I probably have you so confused. The real y. I've started and stopped so many things here. I am so sorry. The real y, we only had it when it was positive. We never went back through and finished this. Otherwise, when signs is 2 or 4, right? 2 or 4 are options. We have to keep going here. Then the numeric value is, I feel like I did this, -1 times the y-intercept. Oh my goodness. I hope I don't have you completely confused now. All right, so now this makes sense. Let's just go over what's happening here. So the real slope is when the random numbers are 1 and 2, the slope is positive. Otherwise, the random numbers are 3 and 4, slope is negative. For the y-intercept, the real y-intercept, when the random numbers are 1 and 3, the y-intercept is positive. Otherwise, the random numbers are 2 and 4, so the slope is negative. Here, I'm pulling in the slope and the y-intercept from the graph component that the students are manipulating the points. It's calculating their slope and y-intercept. We're pulling it into this component. Now I need to check. And started moving things around. I'm almost tempted to restart this video because of that. Oh no. I'll keep going. All right, now I need to check. I need to know that the real slope is equal to the slope they're putting in the graph. So the real slope is equal to the graph slope. And same with the y-intercepts. I need to know that the real y-intercept is equal to the graph y-intercept. Done. Okay. Now, all that's in there, and I want to be able to look at my dashboard and I want to see a check mark that the student did it correctly. So let's now go into the graph computation layer. And I have all that notation in there. So I'm going to call it check. Again, it's the same name, but I need to pull it from that note component, that variable. So that was in note 1b. Remember, I labeled it note 1B, script, check. Okay, so that's pulling the check part of the note into this component, because this is the only place I'm allowed to use the correct sync. Correct? Well, if the check happens, it's correct. Let's see if it works. All right, so I'm going to preview. God, that feels so good. All right, now if you don't want the students to know how they're doing with this, don't do this next part. I am going to go into this component, computation layer, and I'm going to let the students know if they got it correct. All right, so I'm going to do that same thing. I'm going to pull in that check variable, and I'm going to rename it check. Okay. This again is from note 1B, script, check. All right, now I just need a name of a variable. I'm going to call it variable. I'm super creative that way. So when check happens, here's your feedback. Otherwise, here's your feedback. So you all know that I like to use these emojis. I use the green check mark when they're right, the red X when not so much. Why did that not show? Y'all want me to freak out on you? Give me a... All right, the content of this note. I like to use this. My students are used to it now. Done. It's all done. Okay. Preview. Watch this. Watch this. Oh. Here, you just come here. So here's what you can do if you want to make like a whole practice thing for your students out of it. Click on the screen up here. I'm going to do a Command C and a Command V. Now there's two problems like that. I'm going to do that again. Click, Command V. Now there's 3 problems. Now there's 4. Let's say I want them to put a button so that they can just go to town and have lots of fun with it. So screens 1, 2, 3, 4, it's randomly generated. You get what you get. You don't get upset. You just do it. Screen 5, I'm going to let them have a button where they could do one, check it. Click a button, do another one, check it. So they could sit on screen 5 literally forever. What do I want it to say on my button? Get a new equation. All right, now what you'll have to do, press count. That's it. Now, when they come in here, right, preview, every student gets their own unique equation for each screen, but then screen 5 will be like, you're doing whatever you want here. Okay, wow, you know what? That was a lot of fun. I know this is my longest video ever. My initial plan was to make them short and sweet, but I guess coding just doesn't work like that all the time. So I am going to put a link to this finished product in the description. So if you want to grab this and use it, you certainly can, and modify it however you like. Comments are definitely appreciated. Emails too. For those of you who actually know what you're doing and want to say, Nora, no, do it this way, that's cool. Thank you so much. Okay,